Find f prime of x from first principle. F of x is equal to 3x minus 1 over x. Solution: f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h, which is the limit as h goes to 0, x plus h minus 1 minus, of course, x over h here, x plus h minus 3x minus 1 over x. This guy multiplied by 1 over h. So that we get the limit as h goes to 0. The common denominator inside here is x plus h. Here is x plus h. X plus h in x plus hx, we'll get x and then multiplied by 3x plus 3h minus 1 minus x plus h multiplied by 3x minus 1 multiplied by 1 over h. This is the limit as h goes to 0. We do the expansion on top, we get 3x squared plus 3xh minus x minus 3x squared minus x plus 3xh minus h over x plus h multiplied by 1 over h. On top there, we have the limit as h goes to 0, 3x squared plus 3xh minus x minus 3x squared plus x minus 3xh plus h over x plus h 1 over h. So this and this one will cancel. This and this one will cancel. And then we'll remain with the limit as h goes to 0 of h 3x minus, in fact, this and this one will cancel. So we just remain with h over x plus h multiplied by 1 over h. So this h and this h will cancel. And then we'll get the limit as h goes to 0, 1 over x plus h, which is equal to 1 over x plus 0, which is 1 over x squared. Let's check if this is indeed the derivative, or maybe we have made a mistake. So let's check. How do you check? You use quotient rule. Let u be 3x minus 1. and v be x. Differentiate u, you get 3. Differentiate v, you get 1. So u prime v minus v prime u over v squared. U prime is 3, v is x, minus v prime is 1. So we just have 3x minus 1 over v squared is x, and then you square it. So you get 3x minus 3x plus 1 over x squared. This gives us 1 over x squared, which is what we got here. A very, very nice question.
So,
Hello.
so for such questions, you can be actually, after you find the answer, you can be doing a quick one. You verify using whatever method you can use depending on the question.
Or you can use that method before attempting such, you know the direction.
Thank you, sir.
Questions from this one arising. Any statement?
So I was asked if you can explain again on the same example.
Anyone else?
Sir, what's really the use of 1 over h at the end of the brackets
It's the
in
formula.
this case?
That is the formula for the first principle. This is the formula here. That's where this h is coming. Okay. Every time you're given a function f, you're asked to use first principle, you get to the formula. This is the formula. Substitute. What we mean by f of x plus h? Where there's x here, take x plus h, f of x, copy the way it is. So we have here over h. And then these are fractions. If I'm doing fractions, the first thing to do is to combine them. So I get the common denominator. And then divide this guy in here, you get x, you multiply by its numerator. This guy in here, you get x plus h, you multiply by its numerator. Then you do the expansion there as this h is waiting. Cancel what is common until you have an h from top, that's going to cancel the h that is down. Once this h is cancelled from down, you are now free to substitute where there is h, you take 0, which happens here. And then you get the solution. Any other?
Sir,
Huh?
Yes, that 1/h outside the bracket. Why is it there?
It's in the formula here. If you have b over h, it's the same as you have b multiplied by 1 over h. Okay. Another one. Very, very nice. Given that y is equal to x to the power 3 minus x squared minus x plus 1. Find 1 stationary points. Two, state the nature of the stationary points. Three, determine the interval where the curve y is increasing and decreasing. Four, sketch the curve. We follow the order. Solution. This is a very serious exam question from the paper 2012 academic year 19th August 2013, set by Mr. Uncle. First one, to find the stationary points, you need to find the critical number. Stationary points are the turning points. Okay, so use the word stationary because it may not necessarily be a turning point. Like in that curve which you saw where we had a curve of this nature, it was not necessarily a turning point because the function did not turn going down or anywhere. It continued going up. That's why I'm using the word stationary point. So a function may rest and continue its journey. So to get the stationary points, you first find the first derivative. So we get y prime, which is equal to 3x squared minus 2x minus 1. And then equate this guy to 0. So you are solving 3x squared minus 2x minus 1 is equal to 0. This is a quadratic whose product is -3 and the sum is -2. So you have 3x squared minus 3x plus x minus 1 is equal to 0. So we get 3x, x minus 1 plus 1, x minus 1 is 0. So you get x is equal to 1 or x is equal to -1/3. These are the critical numbers. They are not yet points. They only become points if you find the corresponding y coordinates. To find a corresponding y coordinate, you take this critical number in the original equation. So you get y, when x is 1, we have 1 minus 1 minus 1 plus 1 which is equal to 0. So we have a stationary point. So first we find another one. Another one, when x is 1 over 3, negative 1 over 3, we get negative 1 over 3 to the power 3 minus negative 1 over 3 to the power 2 minus negative 1 over 3 plus 1, giving us 1 over 27 negative minus 1 over 9 plus 1 over 3 plus 1, 27 down, and then we get negative 1 minus 3 plus 9 plus 27, which is equal to 27 plus, okay, first 9 minus 4 is 5. 27 plus 5, that's 32. So we get 32 over 27. So the stationary points that we are dealing with here, the stationary points are 1, 0 and negative 1 over 3, 32 over 27. These are the stationary points. Part 2 says, state the nature of the stationary points. To state the nature, you find the second derivative. So we'll get 6x minus 2. In the second derivative, substitute the critical numbers, the x values. So what is y prime prime of 1? That will be 6 minus 2, which is equal to 4. When the second derivative is positive, the stationary point 1, 0 is a minimum point. That is its nature. We get the second derivative, substitute negative 1 over 3. We'll get 6, negative 1 over 3 minus 2. This is negative 2 minus 2, which is equal to negative 4, less than 0. When the second derivative is less than 0, at that critical number, the stationary point negative 1 over 3, 32 over 27 is a maximum point. You may wish to use the word relative, even here, relative maxima or minima, if you are not sure whether the curve is going to come out like this, because if it comes out like this is not the maximum, it is relative maximum because you have numbers above it. This is not the minimum, it is relative minimum because you have numbers below it. That's the meaning of relative. Determine the interval where the curve y is increasing and decreasing. You can use the nature of the points to know where the curve is increasing or decreasing. Because for this point to be maximum, and then this one becomes minimum, it means that before the point, the points are negative 1 over 3, 32 over 27. That's a point. We also have 1, 0, another point. For this to be maximum, the function was increasing, and then it starts decreasing. It starts decreasing. And for this to be minimum, the function started increasing. So we know that this interval here, the function is increasing. This interval here, the function is decreasing. And this interval here, the function is increasing. Using the nature of the stationary points that you have found, we can answer part 3. So we are saying increasing on negative infinity.
Sir,
Hello.
can I please see the previous page? Okay, thank you.
So negative infinity all the way up to negative 1/3 union 1 all the way up positive infinity. So that the decreasing interval is going to be negative 1/3 all the way up to 1. And then part 4, sketch the curve y. So the only thing that we don't have.
Sir, I don't know if you can repeat on the determining the interval.
So to determine the interval, since we have found the critical numbers, we have found the turning points, negative 1/3, 27, is it? 32/27. And so this is a turning point. We've also found 1, 0 to be another turning point. This is maximum. For it to be maximum, the function must be in this form. That's when we say it is maximum. For this to be minimum, it must be in this form. That's when we say it's the minimum. This means that going to the maximum, something must be increasing. Going to the minimum, it must be decreasing until it reaches the lowest. You can't reach the lowest if you are increasing. And then it must be increasing after the lowest. So we call this increasing, decreasing, increasing. To have a full sketch, we need this intercept here and this intercept here. This is already the graph. So what is the y-intercept? Go back to the question. When x is 0, the y-intercept is 1. And we already have the 1 x-intercept. So just remaining with 1. The one on the left. And on the left, we have a polynomial here. Our polynomial is y is equal to x to the power 3 minus x squared minus x plus 1. So we've already found that 1 gives us 0, meaning that 1 is a factor. So we can use 1 with synthetic division as we equate this to 0. So we get 1, negative 1, negative 1, 1. Drop 1, we get 1, add 0. Multiply 0, add negative 1. Multiply negative 1, add 0. Then we get x minus 1, this guy here. X squared minus 1 is equal to 0. So this is 1, we know. And this guy minus 1 is 0, meaning that x is 1 or x is negative 1. This one is already known, so this point is negative 1. And the graph is complete. We have sketched the curve, indicating the turning points. And
Now,
the
sir,
intercept.
in terms of interval, how did you know that negative 1/3 is not included
or
No,
1?
because you have put the stationary point. At the stationary point, nothing is happening. It's not increasing, it's not decreasing. That's why that's why we call it stationary point.
All right, thank you.
So you never include stationary points. We are talking about increasing or decreasing. Very, very dangerous. So this is how our classes are going to be towards December. So it was like this today because it's towards Sunday where we have a paper to write. Don't miss.
Someone not ready.
And if you
Will
miss,
this be included, sir?
exactly.
Sir, can we have some more time?
No,
Yes,
sir. The
sir,
same time is okay.
postpone the day.
Not time. So one,
Yes, sir. The same time is okay.
yes, it's okay. This is a very good
Yeah.
timing because we want to use it for revision. We have another one next month and another one in November, the last one. So if you miss, because it's beyond control, you don't even need to explain to anyone why you missed, because even if you explain, you would have missed. So you just join in the revision. Because I'm not encouraging missing. So even if you explain, I won't be that much happy with the explanation.
Sir,
Eh?
will it be from set theory to calculus?
It will be the whole syllabus.
That's fine.
Yeah.
It's really packed up.
The whole course out.
Sir,
Hello?
I'm asking
Including
for
binomials, sir.
question 2.
But I know we did. So it's a must.
Sir, we haven't done partial fraction and matrices. How are we going to?
Even what you haven't done, you are going to have 7 questions, answer 5. You may not have touched everything as you are going to the exam. So how do you
46.
survive if you find that what you touched is just in 3 questions? How will be the environment? That's what
Sir,
I
me,
want to
I'm not
expose you.
understanding.
Yeah. Don't worry.
Oh, it's the whole course outline for
Everything.
hey.
Look, there will be 7 questions. Out of 7 questions, answer 5.
Mpasande hapo manje.
Yes, Sunday at 14 hours. Sunday
This coming Sunday.
on the 26th, if I'm not mistaken. Yes. 14 to 17
Sir, we
hours.
done learning or what?
We are done.
We're done.
Have a good night. Yes.
Hello, sir.
Hello?
Sir, have you finished? Sir,
You know?
Sir, you can
like after,
YouTube see.
sir, like after you found those is it where the graph has cut the x and the y. Are those the ones that you found there? The x is equal to 1 and x equals to 1, the x is equal to -1.
Yes.
What about? I'm able to see this point here, where on the y-axis is where the graph has cut. I don't know why is
This
that
one.
solution for? Yeah.
It's cutting at 1 when x is 0 in the function. You get 1.
When x is equal to 0.
That's how you get the y-intercept, always.
Okay. But okay.
You know?
I get.
Hello?
Yes. I'm kindly asking for question 3. How you found those in values?
What do you mean question? How we found the intervals?
Yes, sir.
These intervals are asking us to determine where the function is increasing and decreasing. Now we are saying if you are told that a certain point is maximal, for something to be maximal, it means that before that point, it must have been increasing. Okay, and then
Sir,
to start coming down for this to be maximal. For the other number to be minimum, it was decreasing, then it started going up. Then you call it minimum. So when it is increasing, we say this is the increasing interval, decreasing interval, increasing interval.
So my question is, how did you find negative infinity to -1?
To -1/3. All the way from this, since we don't know where it's ending, we are saying all the way from negative infinity up to -1/3, the function will be going up. That's the meaning of this. And all the way from 1 going this side, we don't know where to end. The function will be going up. That's the meaning of this interval. And from -1/3 to 1, for x values, the function will be going down. Is it okay?
sir.
Mhm.
Yes, sir. So this will be part. You'll be in the test as well.
Everything.
Then, sir, I've got 2 questions, if not 3.
Okay.
Yes, sir. Sir, the first one is I was caught out on the piecewise functions, especially the modulus piecewise functions. Then the third one is me. I'm quite behind, sir, on the physical classes. I don't know if they take place. I'm in school, but I don't know what's happening, sir.
Sir, in terms of trigonometry function, in terms of plotting, the one which you use, the simplest one. If you have time, can you revise on that one? Because the other one of drawing and then flipping through a graph, that one will not go.
No, since we have an exam which will have trig, when we revise the exam, we're going to revise how to sketch. That's the main reason why we have that exam, to help us revise the full course.
Sir, thank you very much. Okay.
There will be matrices.
Maybe integration will be there.
There will be induction. There will be
Maybe
integration.
Sir.
I said it will be the
Induction
whole
is
course.
not part of our it's not
Even
part of
partial
our course
fractions.
outline.
It is.
What are any induction?
I said there will be 7 questions.
No.
Answer 5.
User user is destroyed. Yes, even the question which we knew when we were in secondary, we are failing here. Because those are the gradient. Yes, those were easy.
Okay, let me now start uploading the videos.
Sir, wait before you go, sir.
The 1 second, so you can start talking.
Yes, sir. So about the physical classes, sir.
Even on Thursday, there's another one at 16 hours.
Even tomorrow, sir.
Tomorrow there's chemistry.
Oh, chemistry tomorrow. Oh. Okay, sir.
Instead ya kumwona graph turemona butane.